applications that you need to run your organization. Most large enterprises have huge existing app portfolios that are built with traditional architectures, possibly monolithic, N-tier, ESBs, etc., and traditional languages, Java, .NET, maybe C++, or even mainframe applications. You're supporting stateful and stateless workloads, building new apps, modernizing some of those existing apps on new architectures such as microservices with newer languages and frameworks, Spring, Quarkus, Node.js. And you're moving now to integrate more intelligence and newer models into your apps with analytics, AI, ML, event-driven architectures, serverless, etc. You're probably already using multiple clouds in addition to your private cloud and data center, and you may also be using bare metal and distributing applications at the edge. So your infrastructure is already hybrid. You also are working with new tools and processes to support more agile delivery methods. OpenShift enables you to address all of these challenges. OpenShift includes everything you need to run a hybrid cloud, from the Kubernetes layer to the platform services that help you run your apps, and the developer tools that help you make them, as well as the solutions that enable policy-driven multi-cluster management and security. We're going to cover all of these areas today. OpenShift is available as a fully managed cloud service or as a self-managed platform. Managed Red Hat OpenShift is jointly engineered, offered, and managed by Red Hat and the cloud providers so that you can get started with a Kubernetes service quickly. OpenShift managed services include OpenShift Dedicated, Azure Red Hat OpenShift, OpenShift Service on AWS, and OpenShift on IBM Cloud. These are fully managed for you by Red Hat and our service provider partners. OpenShift Container Platform Plus, OpenShift Container Platform, OpenShift Kubernetes Engine are self-managed offerings that you can deploy in your data center, public cloud, or edge location. Choose the model that best suits your needs or a combination of all of the above. OpenShift anywhere, anyway, anytime. And now I'd like to hand off to Shubha Badvi.
Thank you, Kirsten. Hello, everyone. My name is Shubha Badvi. I'm one of the product managers on the security product management team here at Red Hat. Next slide, please. I think by now, Kirsten, next slide. Thank you. I think by now, all of us are very familiar with this executive order on improving the nation's cybersecurity that was signed last year. And it's driving the need for organizations that supply into the US government to address supply chain security. Supply chain security consists of two key elements: security of the tools and the processes that comprise the supply chain itself, and the software that is produced with the supply chain. A software bill of materials, commonly referred to as an SBOM, is the key to evaluating the software coming into your supply chain as well as the software coming out of your supply chains. It provides a formal record containing the details and the relationships of various components that are used in a specific software package. Next slide, please. So there are a lot of new standards that are emerging to help organizations evaluate the security of the software, the tools, and the processes that comprise the supply chain itself. SLSA, which stands for Supply Chain Levels for Software Artifacts, is one such standard. It also goes by SALSA. SALSA is an OpenSSF security framework. SALSA offers levels, four compliance levels, which in the order to gauge the maturity of your supply chain and also how secure your software and the tools and the processes that comprise the supply chain itself. And SALSA is mapping SALSA to existing frameworks makes it easier for organizations, those who are already using the existing frameworks, to understand how they can match the different SALSA levels. Next slide, please. So Red Hat is investing in tools that are already available with OpenShift to help enterprises meet these new standards. To build, test, and deploy your applications and infrastructure, OpenShift provides two-layered products, OpenShift Pipelines and OpenShift GitOps. Red Hat OpenShift Pipelines is a serverless, cloud-native continuous integration and continuous delivery solution for building pipelines with Tekton. Red Hat OpenShift GitOps is a declarative continuous delivery platform based on Argo CD. Using Argo CD, customers can utilize Git as the single source of truth to manage infrastructure and application configurations. As supply chain security is becoming increasingly important for our Red Hat customers, the key focus for OpenShift Pipelines and OpenShift GitOps teams is to make it easy for our customers to increase the security of our pipeline. To give you some examples, Pipelines team is making Tekton chains, a security subsystem of Tekton CI/CD pipeline, generally available. These Tekton chains will help achieve various SALSA levels for our customers. The GitOps team is continuously improving Argo CD's ability to function securely in a multi-tenant environment. For example, by decoupling the permissions for control plane management from application management. We also understand that secrets management is on top of mind for most of our customers and is a very important part of supply chain security. GitOps is planning a first-class integration to link in with customers' existing secret managers. We also understand that security is just one part of the story. And so we are also making investments in the areas of observability, customization, both for OpenShift Pipelines as well as OpenShift GitOps, adding new features and helping our customers improve the security of their supply chain in addition to these other features. Next slide, please. So when it comes to implementing DevSecOps for application, the OpenShift pipeline is the key integration point. We are here, you will see some of the new capabilities on our roadmap. We are bringing together the capabilities that our individual products, which are part of OpenShift Platform Plus offering offers, bringing them together to deliver a multi-cluster DevSecOps pipeline. You probably remember that the OpenShift Platform Plus offering includes Red Hat OpenShift Container Platform, Advanced Cluster Management, Advanced Cluster Security, Red Hat Quay, as well as OpenShift Data Foundation. When it comes to securing containers and Kubernetes, you have to apply security in DevSecOps way for your applications. And OpenShift Platform Plus offering provides that security for the applications as well as the platform that the applications are getting deployed on. So it offers that DevSecOps implementation at both layers. Now, coming back to the new capabilities that we are offering, it is an opinionated DevSecOps pattern with various security gates for software supply chain security, where security is continuously applied in an integrated and automated fashion right out of the box with just one click, from code to builds to deployments in the DevOps way. As roadmap items, we're specifically working to add the ability to sign images in Quay through our investment in SigStore and the Cosign project, an easier integration of Kublinter for scanning deployments, deployment configurations, and Helm charts, and the ability to sign additional artifacts such as deployments for additional protection against tampering, including validating signatures and admissions. And this is on top of what the OPP portfolio offers today already. Next slide, please. As part of the pattern, policy-based application deployment is achieved with Argo CD in tandem with ACM. Each cluster will run its own instance of Argo CD and synchronize with the central so as to not overload just one instance of Argo CD. The hub cluster is the central management point across clusters. The hub cluster is where lifecycle, deployment security, compliance, and risk management policies are defined. The hub also provides a unified view of health, security, risk, and compliance across your fleet. We have these capabilities in place today. However, they each have their own user interface. Over the next few releases, we will be working to provide an integrated multi-cluster user experience for admin, security, and developer personas in the OpenShift console. And with that, I will be handing off to Brad. Thank you.
Hello, thank you very much. My name is Brad Weidenbender. I'm a product manager for advanced cluster management for Kubernetes. And I'd like to build on what Kirsten and Shuba have shown on the first few slides, the better together theme. And certainly we aim to make it ridiculously easy to deploy your workloads. So hopefully that's resonating. Please advance, thank you. And as customers invest in a growing number of clusters, an automated approach to multi-cluster management and security becomes vital to support that digital transformation and journey at scale. Automation is absolutely required. You cannot deploy these workloads at scale with manual processes. It's just not going to fly. It's prone to error. Auditors and such frown upon those such things. And again, part of the better together theme is how we pull together these Red Hat OpenShift bits as part of Platform Plus. It's a comprehensive portfolio. It covers including multi-cluster management, multi-cluster security. So you have ACM and ACS would be your acronyms there. Container registry, Quay, compute, networking, and storage. We at all the levels to help you innovate across those clusters without limitation. We're going to handle that heavy lifting on the back end with the architecture of OpenShift, whether it's the operators, and the heavy lifting we'll do on the back end. And that customer journey, whether you're starting out on your first cluster or you found yourself in that typical sprawl scenario, and we're focused to help providing those standardized set of tools, as Shuba was mentioning, the consistency across those platforms that'll make it easier to manage those in the same way. And we want to drive across three key focus areas mentioned earlier, and that's the unified experience for all users, developers, DevOps engineers, administrators, data scientists, and being able to have a streamlined experience for all those personas that interact at one point or another as they deploy workloads. It's very helpful to have a common experience. So we're driving towards that. We're ensuring our applications run securely from conception to the left, shifting left to your production, and are compliant with those internal and industry standards. So again, that platform consistency across the cloud is what we're driving at here. And this is a nice slide here that shows all the different components that were just discussed. So it does have the different layers. You may hear this referred to as our layer cake slide. So please advance to 20, please. Next slide. This would be advanced cluster security, and we have the theme of security everywhere with unified experience, platform consistency, very similar to what we were hearing with advanced cluster management for Kubernetes. And we're going to deploy your OCP across any cloud or on-premise infrastructure using hosted control planes. those were referenced earlier. That's going to help drive down the total cost of ownership of some of these functions. Cluster lifecycle for managed OpenShift Kubernetes. Another item we're working towards would be unified cluster inventory across the Red Hat cloud and on premises. We also striving towards improved visibility of operator health. Being able to have your fleet of clusters and know the operator health across those is vital. User workload monitoring of fleet application and workloads. Again, being able to drill down in across a fleet is powerful, and that's another element we're working towards. Improvements in manifest signing with secure software supply chain across the fleet. We heard Shuba talking about that, right? That's very important to keep the entire supply chain secured all the way through, end to end. In the telco industry, that'd be cradle to grave, picking up a phone and hanging it up. We need to make sure the entire transaction is secure as possible. And then we have enhanced compliance and history for audit purposes. We have to be able to demonstrate that, right? And that reduces your security risk, reduces your complexity, and also increases your return on investment, right? Next slide, please. Advanced cluster security for Kubernetes. Thanks. And again, we will have similar themes here as we're driving towards a unified experience. You know, we have an integrated native platform bridging the best of the self-managed and cloud-managed. We want to have security everywhere, again, cradle to grave. We provide the necessary tooling to ensure that code delivery across any environment, right? We're going to do the heavy lifting for you, is that point. Then the platform consistency, one choice, one provider from the data center through the edge tiers. To me, when I sat in the non-vendor chair, the fewer vendors I had to get together for a troubleshooting meetup, the easier it was, right? And that's the better together. You know, we can stay within the Red Hat walls. By the way, I'm broadcasting from beautiful Raleigh, our headquarters here. I hope you can see how nice it is here. And so, again, we'd like to keep all of these Red Hat bits working together seamlessly. And that's the story there. Next slide, please. Here, another part of the Platform Plus Quay, Red Hat Quay and Quay.io. And we will get a fresh user interface experience starting with Quay 3.8, and Quay.io will be shipping in a couple of weeks. This new UI is going to replace the old interface. It'll boost user productivity with a lot more support for batch operations, monitoring the registry, the health of the registry, and growing and getting accurate, in-depth reporting on the security of all your containerized content. Again, all the different components in that layer cake need to be secured, and this is what's going to help that across the entire transaction. And then we have supply chain security. Security remains a major focus for Quay, and that would be said for all of these bits in the Platform Plus offering. In the coming quarters, we'll see the ACS and Quay converge in the same security scanner based on Claire version 4. That'll bring on the reporting on vulnerabilities in more programming language and the frameworks like JavaScript, NPM, and even the binary artifacts like Golang executables, new images like Microsoft Windows containers. And then as well, Quay will also adapt a new feature set of the OCI standard, which allows to link artifacts together, the software bill of materials or signatures to images, and make those transportable via mirroring and surface visibility in the UI. That transportable is something, you know, if you can have portability characteristic, it's very helpful to have that consistency. Automated content management being a central source of truth for all the containerized content. Quay will make it easier to manage that content at scale. And that's, again, the theme you'll see here. We're driving towards helping customers who have that cluster sprawl, have scale. These are all things we're working towards. In the future, we plan to allow to make the replication from other registries for the purpose of HA and DR easier, and then also enabling admins to enforce retention rules around stored content. So we can automatically delete old images that haven't been used for a long time. That'll make your storage admins real happy, and the folks paying for that storage compute, right? The bean counters will certainly be happy when we start getting rid of things that aren't being used, the bit rot that tends to sit out there. And then we have enterprise-friendly SaaS, right? So specifically, we see a lot of additions for enterprise users. We've listened to your feedback, and we're working to provide that standard cloud service certifications as well, published SLAs, and allow for payments using your cloud provider billing account. On top of that, we'll allow you to connect your own identity provider. You'll be able to do all this through the whole Quay experience embedded into the console.redhat, and that drives on what Shubha was talking about, that unified experience. Please, next slide. And then here we have, the OpenShift multi-cluster storage. And again, part of our Better Together, we have the persistent volume level encryption with external key management system. So enabling encryption per tenant, per PV, using the external key management system. We have the ODF, OpenShift Data Foundation, LVMO, OpenShift Data Foundation Dynamic Storage Solution for a single node OpenShift. That's based on the logical volume manager operator. I apologize for all those acronyms. And then the multi-cloud object gateway. This is ODF's data management layer for object storage. And that will allow file system namespace data collaboration between legacy applications that read-write files and cloud-native applications that use, for example, AWS S3 compatible APIs. This also kind of ties into where your journey's at. You could be having legacy applications you're porting over, and it's not a forklift thing, and you'll be slow rolling it in, and we're going to help with that. And then lastly, I think one last thing I wanted to call out is there's going to be optimization to the OpenShift APIs for data protection. That's with the enhancement with the data mover. That's tech preview. And we can go ahead and advance to the next slide. I'd like to hand it off to Oren. Thank you.
Hey, Brad, thank you so much. Really exciting to see all the things that we are currently working on. So we're going to now talk a little bit about Red Hat Cloud Services and what those are. So next slide, please. So what are Red Hat Cloud Services, or what is this, right? So the aim here is to get you the platforms, applications, and tools that you already know and use, but without the toil and headache that goes along with that. We also want to give you a lot of flexibility of choice, but to ensure that you have a consistent experience across those choices, right? Sometimes said choice with consistency. So a consistent experience, whether you're using it on-prem or in your cloud of choice, or somewhere in your basement, right, or your garage. So these offerings are available across clouds, thus able to better cater to your preferences and needs. And lastly, giving also just a full stack management, the unified experience. So providing the managed service through an entire stack from infrastructure, applications, and tools without the vendor lock-in that sometimes goes along with that. Next slide, please. So as I've mentioned, we're talking about the applications you already are familiar with using on-prem and moving them to the cloud. So imagine getting an end-to-end software supply chain built on proven open source tools without any toil, no DevOps, no sort of infrastructure management, and the challenges that go along with that. So we're working in a number of areas, such as software supply chain with hybrid app console build services, Developer Studio, App Studio, GitOps and pipelines with Argo CD and Tecton, multi-cluster workloads, so manage workloads and control plane services, if you've heard of KCP. This is a really exciting area, and I'm excited to see kind of what comes forward with that. And security, right? So managed ACS or advanced cluster security, previously known as StackRox. Next slide, please. So talking about ACS, we're actually excited to introduce a service preview or a field trial of Red Hat Advanced Cluster Security Cloud Service. This is targeted to start in December. And with the cloud service, you're going to get all the benefits of Red Hat ACS, things like vulnerability management, compliance assessments, out-of-the-box security policies, and so forth. And you'll be able to get all that with consumption-based pricing and 24/7 support, in addition to the ability to use any of your committed spends to purchase ACS on the Red Hat, AWS, and Azure marketplaces. So the field trial will be initially only available on AWS, and it is not recommended for production use. But if you are interested in kicking the tires, trying it out, definitely reach out to your Red Hat account team, and they'll be able to direct you in the right direction. Next slide, please. So for those that are familiar also with ACS, you're probably wondering, well, what aspects exactly will be part of a managed service, right? And as you may know, there are different components that ACS has. Kind of the top box in the middle here is it's called ACS Central, and this is your control point and dashboard, and this is what connects to the individual clusters. It does this via a ACS sensor component. There are also other components such as the admission controller that is on each connected cluster, as well as the collector that is also on every node. So with the cloud service, Red Hat will be deploying and managing ACS Central for you. Therefore, you'll be able to really quickly start securing your OpenShift, ROSA, Arrow, Kubernetes as a service clusters, or the one that's running in your basement in just a few minutes and across different geographies. You'll be able to better focus on securing your applications without the headache of managing additional infrastructure. Next slide, please. So as part of our cloud services portfolio, you might be already familiar with our managed OpenShift services, and we have a number of themes that we are directly working on here. One is a unified experience, and this is about improving the availability of creating and managing OpenShift clusters from a single source. We will soon have most of the managed clusters to be able to be created from OpenShift Cluster Manager, or otherwise known as OCM. Both OSD and ROSA are already fully there. We're currently working on ARO, or also Azure Red Hat OpenShift. For example, over the summer, a new UI was released for ROSA. And towards the end of this year, we will begin further integrating ARO into that. One of these consistent experience or unified experience features that will be enabled is the ability to do any sort of version configuration or version selection as it currently exists in ROSA and OSD. Moving on to security, and security is obviously on everyone's mind, and it's in a lot of customer conversations that I have. So in this part, I'm going to focus a little bit more on compliances, because we're going to circle back to security in just a second. But we continue to work through expanding industry compliances as well as offerings in the respective governmental regions. For example, we recently announced that many of the Red Hat cloud services are now HIPAA ready, including ROSA and OSD. In Arrow, we expect to enable the Microsoft Azure Government Region, or colloquially known as MAG, with FedRAMP High in Q1, and are also working on DoD IL5. We've had a number of customer conversations that are asking about compliances such as IRAP and Protected B, and we are currently investigating that for both ROSA and OSD. Consistency, right? This is a message that we're kind of consistently coming back to, or repeatedly coming back to, not to use the same word. But our guiding approach is this, right? If it works on self-managed OpenShift, it should work on managed OpenShift. Obviously, this can't be true 100% of the time, but that is the bar that we have set and that we are aiming towards. And as an example of this, one of the features that we're going to be introducing into ARO to get this consistency is to add back optional infrastructure nodes. So as it currently exists in both ROSA and OSD, to have a, again, consistent experience and architecture across the offerings. Next slide, please. So choice, right? And consistency and choice, again, repeating themes here. So on the ROSA and OSD front, we've been enabling many more instances that you can use for your clusters. We think it's important for you to be able to customize your offering exactly as you need it and to the specific use cases that you need to be working with. So as such, we've expanded the offerings with the X1, X2s, R4, T3s, some AMD instances that have already been completed. We're going to be coming forward with some GPU, wavelength, ARM instances, to name a few, that will be coming in the near future. If you're curious to see what exactly are the instances that are currently supported, I encourage you to go look at the ROSA or OSD docs in the service definition, and you'll see there a list of all the available instances that are available for you to use. On the Arrow front, we've already enabled a first batch of GPU instances. By the end of this month, we will be enabling a second batch of GPU instances, so expanding the number of instances that are available for you and options for you to use with your Arrow clusters. In addition to that, we will also be supporting the M192s, DSV5s, and the LSV3s. We're also making, we also plan to bring out support for accelerated networking VMs, and a large part of our customer conversations have been about the sizes of clusters. So we've heard you, and we're also working on expanding the maximum cluster size to 500 nodes. In terms of regions, we're constantly expanding into different regions. On the AWS side, we're going to be moving out towards UAE and Zurich, and on the Azure side to Qatar and Brazil Southeast. Now, lastly, rounding up the security conversation, and this time a little bit more focused on features. For Rosa, we will be bringing on AWS managed policies, and a large aspect and or theme, right, particularly when doing with security and credentialing in clouds, are short-term token-based credentials. It is a cloud best practice that is really helps better support our offerings across the different clouds, allowing a little bit more granular controls. So there will be some enhancements that will be made to the Rosa UI, as well as work for enabling this in ARO coming forward. We will be working on bringing Azure Lockbox, so better control over what data is available to support team, as well as Azure Key Vault. And lastly, we're also working on enabling UDR for ARO, or user-defined routing, for public clusters, so also known as public IP removal. So if you are going to be deploying a private cluster, you will no longer need a public IP for egress. You'll be able to utilize UDR for that, and therefore increasing the security of your clusters. With that, I'm going to turn it over to my colleague, Marcos.
Thank you so much, Oren. So we are going to put the focus now on the core platform, workloads, as well as developer experience. These provide the foundational feature and capabilities to make the platform better, faster, and easy to use. So let's start with the plans we have for installation updates, as well as provider integration. We are going to continue with the work enabling new platforms and different form factors for OpenShift installation in general. The team is doing a great effort to make OpenShift available on new cloud regions for different providers, and as soon as they are GA, and we will continue on that direction. We are adding support to new cloud providers offerings like AWS Outpost, AWS Local Zones, and we plan to GA the integration with IBM Cloud, which is technology preview at the moment. Cloud providers are extending or offering new authorization services, so there will be a lot of work coming on this space to add new authentication capabilities for each provider that customers are already using or are planning to use to manage authorization for different services in the cloud. We are working to enhance the installation experience for every platform to simplify the installation onboarding process and get this process also adapted to customers' use case, as well, giving the customers the option to choose which components they want to get ready on their cluster from day zero, and remove some operational burden they do have at the moment on day two to disable or enable some additional features that are coming with the platform. We will extend this information later in the presentation, so you can learn a bit more about new installation methods like agent-based installer or hosted control planes, which is going to be available as a technology preview very soon. For cluster updates, we continue to invest in making the over-the-air upgrades robust and improve the update user experience for single-click updates, single command updates, as well as improving timely recommendations and warnings of risks to help administrators to make informed decisions about updates. Next slide, please. We are adding new capabilities to our CLI OC with the CLI manager. This is based on the upstream project crew and will basically allow users to discover, install, and update OC plugins from a single command interface. Next slide, please. Okay, so OpenShift and Bare Metal. On the agent-based installer, the one I mentioned before, we are working on an installation user interface similar to assisted installer, but this is for local disconnected environments, that will run directly from the installation image. For the assisted installer, which is hosted at console.redhat.com and which is GA already, this keep adding valuable OpenShift features, including support for heterogeneous clusters, MC or multi-cluster engine, and HyperShift. On the Metal platform, we are exploring how to manage and deploy bare metal clusters with ACM and MC directly from cloud services, starting with ROSA. Next slide, please. In 4.12, we are releasing the core technology powering Corios layering. So basically, the operating system is shipping as a container, but it's booting as a normal OS. And as a dev preview, you can customize RHEL Corios nodes within your own content. Over the next couple of releases, we will be bringing this to full support, including support to add in extra RHEL packages that we don't ship in Arcos. We are also thinking about how we can change the installation flow to accommodate custom boot images for scenarios where you need to add storage or network kernel drivers, to the install node, as an example. And as I said, you will be able to take the wheel and try out Arcos customization within 4.12 already, coming beginning of next year as dev preview. And please try and let us know how it goes. Next slide, please. So operator management will see an evolution on top of OpenShift. By now, all of OpenShift layer products are delivered via an operator, and we will also be bringing core OCP features like console, internal registry, or certificate management to a set of optional features, OpenShift features you can opt out or opt in via OLM. To make this work at scale, OLM will adopt a new lifecycle model in parallel to the 16.1. On its way to version 1.0, it will gain a new set of APIs that will manage operators at a cluster level, which will simplify the process and reduce cluster resource required to maintain operators significantly. In particular, this will make it easier to provide operators in a multi-tenant clusters. Administrators and SRE teams will have more control over who gets access to which operator, and likewise, the permissions an operators gets granted can be configured more granularly. It also enables administrators to move at their own pace, which refine update mechanisms that allow version selection and semi-automatic updates to newer patch releases of operators. Next slide, please. Compute. So for platform first, we want to enable new workloads and reduce TCO. We are working towards enable OpenShift across more cloud providers, as I mentioned before, and other platforms like IBM Power and C, Power BI, and Power BS. Additionally, we are looking to enable mixed architectures in a single cluster already. We will continue our work on DPU support via the hyperscalers and other data centers. In the future, OpenShift will integrate these specialist systems on chips, allowing you to leverage unique architecture approaches that are essential to success in today's world. For consistency and security in the future, we plan to enable pluggability with cloud-native solutions such as KMS, DNS, and load balancers. With Threat Manager, we plan to enhance its lifecycle management for application certificates and make it general available. We will enable both security admission in restricted policy level by default and migrate existing core workloads to comply to the restricted pod security policy level. For experience, we are focused on inbuilt functionality to help you scale down and scale up your control plane, provide even more comprehensive backups, and handle disaster recovery requirements, all built in OpenShift. We will increase the overall quality for OpenShift out-of-the-box alerting rules, such as reducing alert severity to warning where appropriate, and warning against badly configured admission webhooks that risk stability, for example. Next slide, please. As we continue to grow the ecosystem for Windows containers with support for more cloud platforms like GCP, we are aware that there are a few other key areas that we need to address for this. So specifically, we want to offer the cluster-wide proxy and CSI plugins for storage, and we will also offer better health management for Windows nodes. As an example, a controller running on the node will be able to recognize queue binary crash and work to return the Windows node to a working state. And if that's not possible, an event will be triggered and generated an alert for the cluster administrators to check the issue. As adoption of Windows grows, we will bring support for more third-party plugins for Windows nodes in OpenShift, specifically for Calico, Cisco, ACI, and others. And this is all from my side. Over to you, Peter.
Thank you, Mac. Next slide. Let's talk back one. I think we skipped Sandbox. Thank you. So Sandbox Containers enables Kata containers as an additional runtime to use native Kubernetes primitives and provide kernel isolation for containers between the host and container. So some examples would be a CI/CD pipeline that needs isolation inside of a financial services organization, or where you really need a separate individual kernel inside your workload. Workloads based on Sandbox containers aren't any different. They look and feel the same as normal containers, including how you make a dashboard and how your metrics are viewed. Previously, Sandbox containers have only been available on-premise with bare metal, and we're working to change that in two ways. One, we have a tech preview in AWS for bare metal instance types, and as we move forward, we'll have Sandbox containers available in more public cloud providers. We're working to remove the bare metal restriction by reusing cloud-native APIs to achieve additional isolation with an innovative technology to orchestrate the cloud infrastructure. No nested virtualization. Next slide, please. So OpenShift Virtualization, or VMs in OpenShift, have been used in many different production areas. And we've recently at KubeCon had ecosystem partners like Veeam and Kasten and Trilio announce support for virtual machines in OpenShift. And we're expecting other data protection partners to announce their support in the coming quarters. As you know, OVN Kubernetes is the standard for OpenShift, and we're enhancing secondary networks so you can use security and capabilities like micro-segmentation with virtual machines as well as containers. We're seeing customers scale up their environments. We've published a white paper that showed 3,000 virtual machines under load in a large cluster, and we're looking to scale that up to 10,000 virtual machines in a single cluster. And as you deploy multiple clusters across your environment, we're looking to be able to manage virtual machines within advanced cluster management. as OpenShift increases their disaster recovery story, we're looking to use the Metro DR capabilities that are in ACM and OpenShift Data Foundation to ensure the business continuity for both your container and virtual machine workloads that make up composite application. And lastly, for developer services, it's important that virtual machines can be used in a self-service way, just as containers can, so you can build, test, and deploy virtual machines using a GitOps paradigm with Tekton and Argo CD. Next slide, please. So, migration toolkit for applications. As you can imagine, as an architect, the amount of information to analyze an existing inventory can be overwhelming and massive as you try to figure out your adoption plan for moving different pieces of the workloads over. Later this year, we'll have, updates actually coming will assist giving you insight into this raw information, enabling you to focus and prioritize your adoption initiatives, reducing the risks, and providing certainty upon where you can make decisions about which applications to move. Next slide, please. So for serverless, we're elevating the developer experience for creating event-driven applications with serverless functions. We want to let you focus on the value you want to provide, and not the infrastructure or the container creation behind it. Orchestration and choreography of microservices and functions will be led by a discovery and subscription of events in other areas to increase the ease of use. For security, we're offering that all hops will be encrypted for internal and external services natively as a tech preview, and we're working to make it GA, broaden this. Multi-tenancy is also another area where we're providing capabilities, and that will be with Service Mesh and looking to bring that into Knative itself. And lastly, on the platform side, we're looking to offer serverless everywhere OpenShift is available. Right now, it's available self-managed in OSD, ROSA, and ARO and Azure, and we're working to provide serverless on single-node OpenShift deployments and ARM platforms. Next slide, please. As you know, the developer experience is core to what folks use OpenShift for, and we're looking to improve in 3 different areas: onboarding, local development, and cloud-hosted services. Onboarding tends to be a huge problem, and the integrated development platform is an area we've been following closely. We've been seeing some traction in the Backstage community, and we know that a number of our customers are starting to build IDPs and investigating how Backstage can help them. We've announced that Red Hat will be will be joining this community, and we look forward to growing things and seeing how that develops over time. Local development environments also can be challenging because of lack of consistency and requiring overhead for developers to deploy targets in the final Kubernetes and OpenShift clusters. We've recently announced Podman Desktop to help developers working with containers in Kubernetes, and will allow tools and UI to easily manage containers, minimizing discrepancies between the local developer environment and the ultimate Kubernetes deployment. This will allow you to facilitate transition from containers to pods to Kubernetes. Next slide, please. As you can imagine, there's much more to talk about from the developer point of view, and we actually have a whole separate section here for the developer edition of what's coming. Now I'm going to turn it over to Frank to talk about Edge and Telco.
Thanks, Peter. So next slide, please. The big news, as announced at KubeCon in October, is that we are productizing MicroShift. MicroShift is a low-footprint Kubernetes distribution derived from OpenShift. We are bundling MicroShift with RHEL for Edge. We do this to extend our Kubernetes capabilities even to the smallest field-deployed edge device. The product we are announced is named Red Hat Device Edge. Next slide, please. Here is a high-level overview of Red Hat Device Edge. The lower layer is RHEL for Edge. As you may already know, it's an OS3-based, immutable variant of RHEL. The new kid on the block is MicroShift, which can be optionally installed on top of RHEL. It's a minimum Kubernetes distribution that provides API and services necessary to achieve workload portability from OpenShift or other Kubernetes distribution to MicroShift. You can use the same tools and processes to provide consistency across all footprints. Small far edge, single near edge to cloud data center. MicroShift is derived from OpenShift and inherits its proven quality. But please notice that MicroShift does not provide the same OpenShift experience. It brings only the bare minimum components required to provide workload portability from OpenShift to MicroShift. For instance, there is no console, no registry. But on the other hand, MicroShift permits to run Kubernetes workload on a field-deployed edge device with only 2 cores and 2 GB of RAMs. Let's talk now for MicroShift. Let's talk about the roadmap of MicroShift in the next slide. Slide, please. Thank you. MicroShift will be developer preview early next year and GA targeted around summer. As MicroShift is different from OpenShift, we will seek its own CNCF Kubernetes certification. We are focusing on industrial edge computing use cases like IoT gateways first, then extending to use cases around machine vision, machine learning, model inferencing on ARM platform. In the long term, we intend to also support low latency workload. In a nutshell, MicroShift, Red Hat Device Edge, brings OpenShift key capabilities to field deployed edge device. But once again, it's not OpenShift. Next slide, please.
And just a quick reminder, we'll fix the slide. It's Dev Preview 2023 and then GA in summer 2023.
Thanks, Kirsten, and sorry for the typo. So, if you want to have the full OpenShift experience on an edge device, you need single node OpenShift. And here are our major new features for single node OpenShift. We will keep expanding the supported cloud provider and architecture. We will add support for AWS and bare metal on ARM in order to support development of edge workload. Also, we will leverage composable OpenShift to keep reducing the resources required by single node OpenShift. For instance, by disabling the web console to reduce memory need. Slide, please. A telco solution has to be highly available, cost efficient, and highly performant. And this is what makes telco a unique challenge. None of their 3 orthogonal requirements are negotiable. Often, optimizing 2 of them lead to a degradation of the 3rd, and this is unacceptable. This challenge is driving Red Hat investment on the 3 axes, at single node OpenShift scale, at data center scale, at country scale, as you will see in the next slide. Red Hat does enable and will keep enabling all hardware innovation fueling the CNF ecosystem, starting by the historical components that continue to evolve, generation after generation, CPU, NICs, PCI, etc. We also developed the software stack required by new hardware paradigm that could disrupt established hardware designs with SmartNICs and DPU. SmartNICs, offloading flows, may sound like an old news from a marketing perspective, but this is not old news from a production deployment perspective. Also, new generation of SmartNIC needs to be properly leveraged across the software stack. Then, beyond flow offload, DPU value proposal is to save x86 CPU cycle by completely offloading some of the software running today on the x86 onto ARM CPU running on a dedicated card, driving the same SmartNIC already available on x86. So now we have a stack of x86 on top, ARM CPU in the middle, and the same SmartNIC at the bottom. Finally, Some processing is known to be implemented more efficiently on accelerator than on CPU. Historically, cryptography, so we can accelerate TLS and IPsec. And now, 5G data transmission with forward error correction. Next slide, please. The challenges of 5G RAN, so variability. Red Hat already supports a rich set of deployment models to satisfy telco for edge footprint. Single node OpenShift, compact cluster, and multi-node cluster. We're adding to this set single node OpenShift with additional worker node. We're also addressing new networking and timing paradigm, like moving the grandmaster clock from functionality from a self-site router into an OpenShift node, as well as providing encryption for OpenShift traffic when provisioned onto insecure network. Operation at scale. A national telecommunication network may deploy tens of thousands of single node OpenShift. And this is why Red Hat will continue to invest in our operational improvement. We'll see an increase in scale, both in how many clusters can be managed by Red Hat ACM, as well as how many instances of Red Hat ACM can run on the same hub cluster infrastructure. We will continue our commitment to a GitOps methodology with advancements like the zero-touch provisioning and the topology-aware lifecycle manager, tools that help manage a complicated topology in a simple and deterministic manner. Innovation with appliances like performance. Red Hat will continue to add support for next-generation hardware that our telco customers require, as seen in the previous slide. Also, as the hardware vendors are improving power management on their hardware, our ecosystem, our open ecosystem, will allow Red Hat to leverage these capabilities across the stack, and we will see an outlook in the next slide. Telecommunication service provider wants to reduce power consumption and to deliver new services in the most power-efficient way. We want to satisfy this desire by allowing for power savings at all layers of the solution. Starting from the bottom, we will allow OpenShift operator to start a server with the lowest possible power mode. Zero-touch provisioning will allow the cluster operator to configure and validate BIOS settings prior to provision a cluster to ensure the hardware is configured correctly from a power efficiency perspective. At OpenShift level, we already have extended the functionality of the performance profile to allow the offlining of unused CPU, and we are working on enabling additional CPU saving features via the power performance pools concept. The power performance pools will give the possibility to configure some CPU in high performance mode and some other CPU in low performance mode, and let the workload pick the power performance profile that fits its power and performance needs. Since some workload pods don't require the maximum performance CPU, it makes sense to allow them to use a lower power processor. Because of RAM, because of the radio access network gigantic scale, saving tens of watts or more per server is a huge overall saving. Back to you, Kirsten.
Thank you, Frank. And as we step into networking, apologies, I'll get my video on in a minute here. All right. So we've been talking about networking in various ways as we go, and also about multi-cluster management. And so, of course, we continue to invest, partly as Frank has mentioned, as Brad mentioned earlier, in improving network capabilities across the multiple networking layers, all with the goal of enabling multi-cluster networking across geographies. We're enhancing our capabilities for single node OpenShift, hosted control planes, hybrid cluster, and working towards globally unified networking. We're going to unify how we handle traffic into, out of, and between clusters so that ingress and egress are configured in the same manner, regardless of protocol and platform. And we want to align how our layered products, such as service mesh and virtualization, operate, as was mentioned by Peter earlier. Not only will this make operations easier, but this will be extensible to current and future networking protocols. We continue to work on Submariner to provide enhanced multi-cluster networking capabilities with Layer 3 and Layer 4 interconnect. With Submariner, your applications and services can span multiple cloud providers data centers, and regions. So we mentioned service mesh earlier in talking about serverless. Again, we continue to invest here. We're working to converge with the Istio community. A lot has changed since we launched Service Mesh 1.0. The project has matured significantly, and this year, Istio joined the CNCF. The Community Istio project continues to innovate, and we want to continue to bring those innovations to our customers, investing in things like Gateway API, providing the next gen of traffic management for both ingress and egress. Also, both ingress and internal mesh traffic. Also, ambient mesh, an experimental data plane for Istio that avoids the need for sidecar proxies. Service mesh at scale. We have customers that run meshes over hundreds of namespaces and thousands of services across multiple cloud clusters and cloud providers with very complex needs. We're working to ensure that our enterprise customers are able to secure, observe, and manage service mesh traffic at scale. Finally, with consistency, we're focused on a cohesive experience between Istio, OpenShift Service Mesh, and the OpenShift platform. This includes a Service Mesh extension to the OpenShift console, integration with Cert Manager, monitoring, GitOps, and more. We're also heavily investing in network observability. As networking gets more complicated, customers expect improved tooling to understand what's happening below the application layer of their stack and to optimize it. In the network observability operator, we've created tooling within the OpenShift console to provide the information customers require to observe the network traffic to and from their applications, and we've made it easy for them to understand that information, whether they're working with one or hundreds of clusters. Network architects, cluster operators, and administrators and developers alike will benefit from this tooling. The network observability operator uses an eBPF-based agent on each node to efficiently gather metrics and provides a wide range of networking information using relevant standards and protocols from the industry and to live stream or snapshot in time using components such as NetFlow, IPFix, and SFlow. Using the network observability operator, the complexities of networking in a Kubernetes environment can be reduced to an easy-to-understand graphic or table of information. We're also heavily investing in observability. We often say in my world, you can't secure what you can't see. So observability aims at providing a simplified and consistent experience to users who need to turn data into answers. Of course, observability is not just about informing security, but also informing health and performance for your solutions for the applications running on the cluster, as well as the cluster itself. OpenShift Observability focuses on 5 pillars: data collection, data storage, transportation, visualization, and analytics, encompassing multiple data sources, metrics, logs, and traces. With the previous slide in mind, let's take a closer look at upcoming features. We've recently introduced Vector as a log collector and Loki as log store, as well as OpenTelemetry as traces collector. This is currently in tech preview. Coming next is the observability operator, which provides users with a cluster monitoring Prometheus experience. For virtualization flexibility, we focus on the console to provide observability users the ability to easily query, search, filter, visualize metrics logs and metrics targets, reducing noise and enabling them to focus on the data that matters. With logging 5.6 in OpenShift 4.12, we continue to focus on improving user experience, facilitating navigation, data exploration. Users will soon be able to explore logs via the developer console. And for analysis, we help you take a closer look at your data by combining visualization and advanced searching and filtering capabilities in the console. Again, coming with 4.12, users will be able to explore runbook URLs for alerts via cloud.redhat.com. Details about the exact features will be available in later this calendar year. and can be found in the appendix roadmap session. That's what we have for you today. Thank you so much for your time, and looking forward to the next conversation.